Okay, so we have seen in the previous video relationship between mean and arbitrary point. Now we'll see the ulta of it, that is relationship between arbitrary point and mean. Arbitrary point and mean. Simple. If I am finding the relationship between mean and arbitrary point, I'll write the mean formula and insert somehow the A and then try to get a relationship between mean and arbitrary point. If at all, if I'm finding it ulta way, that is arbitrary point and mean, I'll write the formula, the rth moment formula for arbitrary point and insert in that somehow the mean x bar and then do some manipulations or mathematical calculations and get things done so that I get a relationship. Because of which what I will do, I rewrite this rth moment about arbitrary point formula by adding and subtracting x bar. Okay. So anyways, I know x bar minus a is nothing but mu1 prime, right? Now, xi minus x bar, let me rewrite it to be zi because along with xi values, z keeps changing. So z should be zi. Now, mu r prime, when rewritten, would look something like summation fi zi plus mu1 prime power r. Again, if I have all binomial coefficients only, guys, but only thing is here it is plus for the relationship between moments about mean and relationship between moments about mean and arbitrary point. There was a negative sign because of which in the binomial expansion there are alternatively plus minus signs, but here it is a plus sign. So the similar binomial expansion will be there, but all positive signs only will be there because zi plus mu1 prime is there. Okay. So how will it be? Power r na, power n if it is there, nc0, nc1 like that we will write. It is power r. So rc0, zi power r, mu1 prime power 0, rc1, zi power r minus 1, mu1 prime power 1. Okay. rc2, I'll write one more term and then stop because you understand the rhythm, right? zi power r minus 2, mu1 prime whole square and so on. Things will go on. RCR till RCR, they'll go on. Okay. Yeah. So if I take the summation fi by n inside, what I'll get will be RC0 summation fi zi power r by n is what I will have. Similarly, for the next one, I'll be having RC1, mu1 prime has nothing to do with the summation because there is no I term there. Okay. fi zi power r minus 1 by n plus RC2. Of course, mu1 prime whole squared has also nothing to do with the summation I, right? So summation fi zi power r minus 2 by n is what I'll have plus and so on. Okay. Yeah, of course, the our last one will be RCR. Okay. Yeah, right. So this is the formula. Now in this, I'll be inserting RC0. R is equal to 0, R is equal to 1 and all the things. Of course, 0 and 1 I have already calculated. So I'll be going with RC2. I'll be starting with RC2. Okay. Yeah. I'll just show you. For R is equal to 2, it would be something like this. For R is equal to 2, I'll be having mu2 prime. This is equal to 2C0 plus 2C0 plus 2C1 mu1 prime mu1 plus 2C2 mu1 prime whole square. Okay. Yes. Now, this is, of course, in this, let me put one more thing. Summation fi zi, here I have put here I have put xi minus x bar na. So let me write something about it. Summation fi xi minus x bar whole power r by n. This value is nothing but mu r, guys. Mu r. It is nothing but the moment about rth moment about the mean, right? So it is nothing but mu r. So here I'll be having accordingly mu r is equal to 1. Okay. For r is equal to 2, I have written things, right? Mu prime. Now, this is nothing but 2c0. 2c0 would be what? 1 only. So, mu2 plus 2 mu1 prime mu1 plus mu1 prime whole square. Okay. 2 2c0 mu2 this is. Okay. So 2c0 is 1. So mu2 is what I'll have. Now coming to mu3 prime, guys. Of course, I can rewrite this. I can clearly see there's a simplification part here, right? So what that is mu2 prime is equal to mu2 plus mu1 prime whole square. Okay. Why? Because I know that this value mu1 is equal to 0. This is the simplification that I have here. Right? Now, for r is equal to 3, it is mu3 prime. This is equal to what I'll be getting is, you can just check mu3 plus 3 mu1 prime mu2 plus mu1 prime whole cube. Again, here I'll be having a mu1 term which will go to 0 because above the mean, the first moment is 0. Second moment is nothing but variance that we have seen anyways. Okay. Similarly, mu4 prime also I'll be having. What that would be is, you can just simplify. 4c0 would be 1, mu4 plus 4c1 would be 4, mu1 prime, mu3. Again, you can check the suffixes. For 4, all the suffixes sum is 4. Okay. So 6, 4, 6, 4, like that only it will come now. So 6 mu1 prime whole square, mu2 this is. Okay. Yeah. Plus 4, 4 into 4c3, 4 into 3 into 2 by 2 into 3, 2 into 4 c3 na 3 into 2 into 1. So it would be 4 only. 4 mu1 prime whole cube, mu1. Wherever mu1 is there, it will go to 0. Okay. Yeah. Plus 4c4 would again be 1. Mu1 prime whole power 4. Anyways, mu0 power 0 would be 2. Okay. This is how I'll be getting. This term will vanish off. So finally, I'll be having what? Mu4 prime is equal to mu4 plus 4 mu1 prime mu3 plus 6 mu1 prime whole squared plus mu1 prime whole power 4. Actually, they are all binomial coefficients. And in the moments, relationship between moments about the mean and the arbitrary point, what happens is, mean and the arbitrary point, what happens is, because of the plus minus signs, there'll be a simplification. Okay. And then the coefficients 1, 4, 6, 4, 1 gets reduced to 1, 4, 6, 3, 1 kind. Okay. Here what happens is, because of that mu1 being 0, wherever mu1 is there, those terms will completely vanish off. Okay. That's how you will just try to remember with some common sense. Okay. Yeah. So now in the next video, I shall do a problem on this. Okay. An interesting problem on it. With this, I'll end this video.